October, November 2022, Paper 5, Variant 2. Question 1. This question is the reactions between the calcium carbonate in the eggshells and the acid. After the reactions between the calcium carbonate and the acid, the remaining acid, it was titrated with the alkaline solution. After that, we will know what is the acid that remains in the after the reaction. Okay, so let's start this step. Okay, this step is too long. I just roughly discuss what is happening. First, we prepare the eggshell and make sure it's dry. After that, grind this eggshell to powder. Okay, then we need to take about 2 grams of the eggshells, okay, into the conical flask, and we add the acid, 100 cm cube, 2 mole per dm cube HCl, and let these two react. The acid is in excess, so the eggshell will finish react. So after that, we need to pour the remaining acid solution to the filter. So filter the solution. After that, we top up the filtrate in this 250 cm cube volumetric flask. After that, top it up, top to the calibration mark with distilled water. Then after we prepare this solution, we just take 25 cm cube from this solution to 25 cm cube from this solution for the titration. So we titrate 25 cm cube of the dilute acid solution, means the one that unreacted HCl, with the sodium hydroxide 1 mole per dm cube. So this is the reactions about. So means after the titration, we will get the moles of the sodium hydroxide used. After that, we will know the moles of the HCl. Because we know the mole ratio is actually 1:1. So means when we find the moles of sodium hydroxide, then we can find the moles of the unreacted HCl. So I hope you understand the whole the reactions. This is a reactions about calcium carbonate react with 2 moles of acid, form the salt CO2 and H2O. So the remaining acid, as I told you just now, will react with the sodium hydroxide and form the salt and water. Okay, so of course in this question, the first part that you need to calculate is the moles of the sodium hydroxide. Then you can get the moles of HCl. Okay, later we will discuss about the calculation. Now let's start with part A1. Suggest how the student could confirm the eggshell is completely dry in the step 2. Okay, let's go back to step 2. Step 2 is the eggshell is warm in an oven until it's dry. This one, the oven is actually lower temperatures than the furnace or Bunsen burner. So it's better we dry the eggshell or the compound in oven rather than direct heating. Okay, so how we make sure it's completely dry means we have to heat that, reheat, reweight until we get the constant mass. Means the mass, first mass and second mass and the following readings, they are close enough. Part 2. State why the eggshell is made into powder in the step 3 before making up the solution. So this one is a very easy question. We want to grind it into powder because when it's powder form, it's a higher surface area and it will increase the rate of reaction, means it can dissolve faster. So means we kind of make sure it's easy to react and it can finish react faster. Okay, part 3. Suggest what or why the solution is left for 2 days in the step 6 before used. 2 days means after the eggshell dissolves, we still left it for 2 days. Why? Because we need to make sure all the eggshells or the calcium carbonate has been dissolved. Or you can say that to ensure the reaction is complete. Then we can use the acid solutions for titration. Okay, this is very easy question. Part B. So now the table 1.1 is given. So we need to use this mass. Don't use the mass that given in the procedure around 2 grams. So we need to use this value because this is the one that used in the reaction. 2.136 gram. After that, the titrations. Okay, titration, this is the table 1.1, the volumes of the sodium hydroxide that used. So 1 rough and 3 accurate. So just calculate, you get this value, 16.55 for the rough. First one you get 16.3, second you get 16, and the last one you get 16.2. You just use the final minus initial, you get this difference. And please make sure all the values that you put here, it must be 2 decimal places because it's the burette reading. And it must be to 0.00 or 0.05. Part 1. Complete table 1.1 calculates the mean titer. Mean titer, we need to take the concordance titer, means their volumes is same or less than 0.1. So because this is 16.3, this is 16.2, their difference is 0.1, so they are close enough. So we use these two and get the mean. So we don't include this one because this one is much different from these two. 16 actually 0.2 difference with the last one, and this one is 0.3 difference. So that's why when we calculate means, we don't include this one. So we just use the 2 concordance titers, right, which their difference now is 0.1. So use these two, sum it up over 2, you get 16.25. After that, part 2 calculates the amount in mole of unreacted HCl in the solution prepared in the step 7. Step 7, let's go back, then you know what is the step 7 about. Okay, step 7 is the one that being prepared, means 250 cm³ of the solution, means is the one before the 25 cm³. So this is the after the preparation. So 250 cm³. Because in part 1 we already know the moles or the volumes of the sodium hydroxide. Part 2, before you calculate these amounts of HCl needed, at least you need to show this part. So moles of sodium hydroxide, okay, so it's mv over 1000, so concentration is 1 mole per dm³, and the volume is 16.25 over 1000, so you get 0.01625. Okay, after that, we know that this mole ratio is 1 to 1 ratio, but 1 to 1 ratio is when we use 25 cm³ of the acid solution, because now it's asked 250 of the solution. So therefore, the numbers of moles of HCl in 250 cm³, it must be 10 times. So because it's asking 250 cm³, not 25. So means you use the moles of the sodium hydroxide that obtained. So this one also same as the moles of HCl in 25 cm³. So in 250, then you need to times 10 here, right? So you get 0.1625 mole. After we get this mole, then we continue. Calculates the moles in the calculate amount in moles calcium carbonates that reacts with excess acid. Use your answer to calculate the percentage by mass of calcium carbonate in the eggshell. So this one, first you need to recall back, or you use the equations that given in the question. So calcium carbonates, 1 mole of calcium carbonates react with 2 moles of acid. Means if you want to get the moles of calcium carbonate, so it must be half of this HCl mole. So because their ratio is 1 to 2. Now, the things that you need to do is find the HCl that reacted. So means you need to calculate this one using initial mole minus the remain. The ones that remain is the one that in 250 cm cube here. Because the acid in excess and these calcium carbonate finish reacts with the acid, and there are still some acids inside the solution. So therefore, we must use the initial moles of acid minus the one that remain, which inside the 250 cm cube. So therefore, you need to do this calculation. Initial mole, you just use the MV over 1000 again. So it's 2 times 100 over 1000 minus the moles that remains in this part 2. So therefore, you know the moles of HCl that reacted. So we need to know the moles of the HCl that involved in this reaction. In this reaction, when we know this mole, then we can get the moles of calcium carbonate. So we know that now the mole ratio between them is 1 to 2, and we already get the moles of HCl that reacted, which is this one. So the moles of calcium carbonate, therefore, is half of the moles here. So means it's going to be 0.01875. Once you get the moles of calcium carbonate times the molar mass, you get the mass. So it's 1.8769 grams. Still not yet finished because it's asking percentage by mass. So you need to use the mass that obtained here, the actual calcium carbonate that reacts with acid, over the mass that taken. So means it's going to be 1.8769 over 2.136 times 100%. So you get 87.9%. So means in the eggshell, it has 87.9% of calcium carbonate by mass. Part C. Name a suitable piece of apparatus which could be used to transfer 25 cm cube of solution in step 8. Step 8 again is the one that used for the titration. Means before we titrate, let's get back to step 8, then you'll be clearer. Okay, step 8 is transfer 25 cm cube from 250 solutions that prepare for the titration. So how to transfer this? Now we must use pipette. But nowadays, in the exam, you not going to just put the pipette, because nowadays you must put a more specific answer, which is the volumetric pipette. So therefore, you're going to put 25 cm cube volumetric pipette. Then this is a better answer because it's more specific. Part D. In step 4, a conical flask is weighed using a balance accurate to 3 decimal places. So this is a first reading. And the balance now is 3 decimal places, means is 0.000. Right? So this is the 3 decimal places balance about. And the mass recorded. The eggshell is placed in the conical flask and the mass increased by 2.136 grams. So obviously this is a second reading. So means in this this statement, already told you that 2 readings taken. And another thing that you need to know is how to get the uncertainty. For these 3 decimal places electronic balance, what we can get, the smallest scale deviation is 0.001 gram. This is the lowest we can get when we measure the mass. So this is, therefore we say that is the smallest scale division. Uncertainties is half of the smallest scale division, means 0.001 over 2. So you get 0.0005 gram. So it's actually uncertainties, therefore is plus minus 0.0005 gram. So use these uncertainties times the numbers of readings that you took over the mass that taken. So because in order to get this mass, 2 readings are used. So 2 times uncertainties over the mass taken times 100%, you get 0.0468%. Part E. State the effects on the percentage by mass if the eggshell is not completely dried in step 2. Not completely dry means in the eggshell, it must have water, right? So first you need to know, it means less calcium carbonate in 2.136 gram powder. So what you need to say is, the percentage by mass of calcium carbonate in the eggshell sample, when it's not dry, okay, it would be lesser than the true value. Okay, reason is what? As some of it was water. So this is the standard answer. If you are looking for the answer, why mark scheme give this statement, and you want to figure out what is this statement about. Okay, see, the measured mass of eggshell would be greater than true value. So what is the true values here? So let me give you one example. If now we try to compare the values. Okay, this one is from the experiment. 2.136 gram. If the eggshell is totally dry, it would give 1.8769 gram. This is from the experiment just now. So means these 2 values, they are true values, which from the experiment, and the eggshell has no water. If, let's say, now it's not dried, let's say we take the same mass, 2.136 gram, means because inside this mass it has more water, therefore the mass of the calcium carbonate would be lower. Means, for example, let's say now lower we get is this 1.6769 gram. So therefore we know that the mass of calcium carbonate that we use is, or we get from this eggshell that not dry, is actually lower than the true value. So that's why we get the first statement, lesser than the true value of the calcium carbonate. And this is the measured mass. So in this statement again, the measured mass of eggshell would be greater than the true value. If now 1.6769 gram obtained, the true value that need to be measured is actually 1.908 gram, not this. So means the true value to get this mass is actually 1.9 something. So now the measured mass here, which is the not dry mass, is larger than the true value. So this is the meaning. why the measure mass of this is larger than the true value? Because the true value is actually lower, supposed to be lower if it's dry. Okay, that's why the mark scheme, okay, is gave this answer. This is the meaning. The measured mass of eggshell would be greater than the true value. Now, last one. The student repeats the method using the same apparatus, but decide use 0.1 mole per dm cube NaOH. In the previous titration, it's used 1 mole per dm cube. Now it used 10 times more dilute. So when used 10 times more dilute means the volumes that needed to use is going to be 10 times. Right? So therefore, what you get is, what you need to use is not 16.25. It needs to be 10 times larger. So it needs 162.05 cm cube. And this one is not good because this volume is much larger than the burette that used. Normally burette we use 50 cm cube. That's why this is the weakness to the experiment procedure, which the volume is too large now. And the burette, okay, is not really that suitable to use. Okay, that's all. Thank you.